Hello, this is Mr. Buffington. Today's lesson is about evaluating expressions. We're going to take a look at an expression, then we're going to point out the terms, variables, and coefficients inside of that expression. Then we'll go ahead and evaluate some expressions. So there's a lot that we have to do today. Let's go ahead and get started. The first expression we want to look at is 4x minus 2y plus 5. That's an expression right there. And a term inside of that expression is any coefficient and its variable. I know we haven't gone over that vocabulary yet, but basically any term would be like 4 and x together. That is one term. All right, that would be our first term. Our second term then would be negative 2y, and our final term would be 5. Remember to notice here that when there's a negative number, that's included in the term. So our terms are 4x, I'll show you, 4x, negative 2y, and 5. Those are the three terms inside of this expression. Now let's talk about the other vocabulary that I mentioned. I mentioned the words coefficient and variable. In a term, for example, the term 7xy. Inside of each term, there are coefficients and variables. Some terms may not have variables inside them if it's just a number, but in this case, we have a coefficient and a variable. The coefficient refers to the number in the front here. The variable refers to the letter or letters that follow the coefficient. So in this case, the coefficient is equal to 7. The variable is equal to xy. Let's look at this expression. Before we evaluate this first expression here, I want to identify the terms inside the expression. The first term is 3x. The second term is 5y. Within those terms, there is a coefficient of 3, a variable of x, and in the second term there's a coefficient of 5 and a variable of y. So we can see inside of this expression we have our coefficients, variables, and terms. Let's go ahead and evaluate this. We're given information. If x is equal to 4 and y is equal to 2, we're asked to evaluate the expression 3x plus 5y. To do that, we're going to substitute the value of 4 everywhere that we see an x inside of this expression, and we're going to substitute the value of 2 everywhere that we see a y. When you have something like 3x, that means 3 times x. So when we substitute the value of 4 in there, we'll say 3 times 4. Same with this. 5y means 5 times y. When we substitute the value of 2 in for y, we'll say 5 times 2. So now we have an expression that we can solve. 3 times 4 is 12, and 5 times 2 is 10. So there is the next step, in solving this expression. And 12 plus 10 is equal to 22. Those are the steps that we would follow to evaluate this expression. Let's look at one more expression. If a is equal to 7 and b is equal to 2, we're going to evaluate this expression. So we take the value of 7 and substitute it in where we see a inside of this expression, and we take the value of 2 and substitute it in everywhere we see b in the original expression. We have 3 plus 7 minus 2 times 2. Now we have to think back to the order of operations. 3 plus 7 is inside of parentheses, so we're going to do that first. 3 plus 7 is 10. And because there's a minus sign in between there, we know that we're going to do this multiplication before we do that subtraction. So we can go ahead and do that at this same step. 2 times 2 is 4. And to solve this expression, we'll say 10 minus 4, and that's equal to 6. Let's look at another type of question before we go. This is actually a word problem, and I'm asking what expression will we use to solve the question. Jim and Jane like to go running in the morning. Jim runs twice as far as Jane. What is the combined distance they travel? Let J be the distance that Jane runs. So we need to say J is a variable, and it represents the distance Jane runs. So we have to look at these 4 expressions and find out which one of these will show us the combined distance that Jim and Jane travel. Let's go ahead and start at the bottom. 2J. That means 2 times J, or twice the distance that Jane runs. Is that going to be the combined distance of Jim running twice as far as Jane and Jane running? That's not. That's just going to be 2J is going to be as far as Jim runs, twice as far as Jane. Maybe I should have used names that had, like, I don't know, Elsa or something. Maybe we wouldn't have 2 J's in there. I don't know. Anyway. This one here says 0.5 times J. That's half the distance, 1/2 times J, or 1/2 times the distance that Jane runs, minus the distance Jane runs. That's not going to help us out very much. How about Jane's distance divided by 2? Again, that's not going to give us what we're looking for. The first expression we have here says J, or the distance Jane runs, plus 2 times the distance Jane runs. That shows Jane's distance, the first one, and this would be Jim's distance, right? 2 times Jane's distance is equal to Jim's. So this first expression gives us the expression that will solve this question. All right, I know that's a little bit more complicated than the other things we did, but it's important to understand with variables that they represent something. So in this case, J represented the distance Jane ran. So we had to translate, and we're going to do more practice of this type of question, and of actually translating word problems into math sentences or math expressions. So we're going to see more like this. I just wanted to give you a bit of an introduction to that and see how we will use expressions in common everyday situations. I hope that this has been helpful for you. Have a wonderful day.